Hi, welcome to the first video of JavaScript fundamentals. In this video, we will be taking a look at var, let and const. These are the three keywords that are used to declare variables in JavaScript. We will try to understand what is the fundamental difference between these, and we will also take a look at the underlying concepts such as scope, hoisting and temporal dead zone, which are really important to get a comprehensive understanding of this topic. And along with these topics, we will also take a look at popular interview questions related to this topic. Alright, so to begin with, take a look at this code example. Here we have a variable that is declared using var, and we are trying to log it before its declaration. So in this case, you get undefined, but if you do the same with a variable that is declared using let, you get a reference error. Why is that the case? It's the same action for both these variables, but the results are completely different. In one case, you return undefined, and in the other case, it causes a reference error. This isn't a quirk or an exception. There are two different rules that are applicable in this scenario, and in this video, we will understand what those rules are so that you can explain such scenarios effectively and with confidence. Okay, let's try to get an overview of what are the differences between these three ways of declaring a variable. Initially, we only had one way of declaring a variable, and that was using var. But later in 2015, when we came across ES6, we introduced let and const as two other ways of declaring a variable. So now let's see what are the major differences between all these three. Scope and hoisting are two different concepts, and we will explain them later in the video. For now, let's focus on redeclaration and reassignment. So redeclaration refers to declaring a variable again in the same scope. So if you have a variable x which is holding the value of 10 that is defined over here, and you're redeclaring it again to contain a value 20 which is different from the initial value of 10 within the same scope, this is referred to as redeclaration. Redeclaration is completely acceptable for variables which are declared using the keyword of var. The second declaration completely overrides the first declaration, and if you were to reference x anywhere in this script beyond line number 6, the value of x would be 20. But that is not the same when it comes to variables which are declared using the let keyword. Let does not allow redeclaration. So if you have a variable declared using let, you cannot redeclare that in the same scope again. If you were to do that, you will be getting a syntax error, something like this. So if I uncomment this line, you can see that VS Code complains that you cannot redeclare a block scoped variable y. So we will take a look at what block scoped means shortly. But for now, you can remember that if a variable is declared using the let keyword, you cannot redeclare it again in the same scope. When it comes to const also has exactly the same behavior. You cannot redeclare that once it's already declared. So if I were to uncomment this line, which would cause a redeclaration, this will result in the same error that says I cannot redeclare a block scoped variable. So that was related to redeclaration. So if you have a variable that was declared using the var keyword, you can redeclare it within the same scope, but for let and const, you cannot do it. That will throw a syntax error. Now let's understand what is the difference in terms of reassignment. Reassigning a variable refers to changing the value that the variable holds. So we have seen that x was declared using the var keyword, and we had overwritten it with x equals 20, and we are now reassigning the value of x to be 30, and this is allowed for a variable that is declared using the var keyword. Same is the case for the variables which are declared using the let keyword. So y was declared using the let keyword, and we are now able to reassign a different value to y, and that is acceptable. So you will get the latest output as 40 because 40 was assigned to y. But for a variable that has been declared using the const keyword, you cannot reassign it to a different value. You can only assign one value during its declaration, and that is final. You cannot change it. This will lead to a type error if I try to execute this script, because I'm trying to assign a new value to a variable that was declared using const. So as you can see, we get a type error, assignment to a constant variable. So to summarize, if you have a variable that has been declared either using var or let, you can reassign it to hold a different value. But if a variable has been declared using the const keyword, you cannot reassign it at a later point. When it comes to scope, variables which are declared using the where keyword are function scoped. So we will understand what is function scoped and block scoped later in this video, but for now you need to remember that if you have a variable that has been declared using the where keyword, that would be function scoped, and let and const both are block scoped. Similarly, for hoisting, a variable which has been declared using the where keyword will be hoisted and it will return undefined if anyone tries to access the variable before its declaration. And if you try to do the same for variables which are declared using let and const, you will get a reference error because of the temporal dead zone. So these two topics of scope and hoisting are really important, and we will cover them in depth in the rest of the video. But before we cover the topics of scope and hoisting, let's understand one important thing related to the const keyword. We have assigned an array of strings to color, and we are trying to add one more color to this array. So most people might think that since colors is declared using the const keyword, this line should result in an error, but that is not the case. This line works perfectly fine. You get an error when you try to assign colors to a new empty array. Why does that happen? The thing to remember here is that const refers to constant reference. It doesn't mean constant value. So when you assign this array to colors, colors now holds the reference to this particular array. As long as the reference remains the same, you can alter the contents of this array, but you cannot make colors point to a whole new reference. That is why this results in type error, and this works perfectly fine. And by reassigning, we mean pointing it to a new object in memory. So as long as you're pointing to the same object in memory, you can make changes to the object, but you cannot point to a new object after a variable has been declared using const. And this is precisely the reason why the push here worked and this line didn't work. Let's now understand scope. Scope answers one question: where in your code can this variable be used? So you have a variable that you have declared somewhere. Scope answers the question, where else in the code can you access this variable? There are three different types of scope. The first one is global. If you have variables that are declared outside of functions, they are accessible everywhere within the file. This makes them powerful. You can access them anywhere, but it also makes it risky because you can accidentally change the value of that variable anywhere in the file. The second type of scope is function scope. So we have seen in the earlier table that variables declared using the where keyword are function scoped. So what that means is they are confined to the function in which they were created. And if they are created outside any function, they will have global scope. The third type of scope is block scope. So let and const, if you use these two keywords to declare a variable, that will be block scoped. A block of code is nothing but anything that has been confined with curly braces. Not just that, a block is anything inside curly braces. So it could be if statements, loops, or even empty braces. Where only respects function boundaries, but let and const respect all other boundaries like if blocks, loops, and as we have discussed, empty blocks as well. Take a look at this code example. Here we clearly differentiate between the scopes of variables declared using where and let. So we have seen that variables which are declared using the where keyword do not respect if blocks, right? They only respect function blocks. So due to that reason, if you try to access a variable that has been declared using the where keyword, you should be able to successfully do that. But if you try to access a that has been declared using the let keyword outside the block in which it was declared, that should result in a reference error, because you cannot access this variable outside the block in which it was declared, since it is a block scoped variable. So where leaks outside the scope in which it was declared because it is function scoped and it doesn't respect the if block, whereas let stays put wherever it has been declared. Now this particular behavior here might look simple, but in real code bases, this could lead to bugs which are extremely hard to identify and fix. Let's take a look at a similar example which uses the same concept of scope. Try to answer what this loop would log and what this loop would log. A hint would be to remember what is the scope of where and what is the scope of let. So this is a very famous JavaScript interview question. Most probably you would have already seen this in an interview. Most people say 0, 1, 2 for both of these, but it is actually 3, 3, 3 for the first loop in which the variable I has been declared using the where keyword. Let's try to understand how is that possible. As we have discussed earlier that where is function scoped, there is only one I for the entire loop. So when the loop runs for the first time, I is 0, but when it runs for the second time, I becomes 1 and it overrides the first instance in which I was 0. Similarly, when the loop runs for the last time in which I would be 2, it replaces the earlier occurrence in which I was 1. And finally, when I becomes 3, it breaks out of the loop and it stays 3. So once we are done with the timeout and we log all the 3 statements at once, you have the value of 3 since 3 was the final value of I. So to summarize, since I was function scope, there is only one I for the entire loop, and by the time we execute this log statement after waiting for a second, the value of I is 3 and we print 3 3 3. So how would you fix that behavior to give the expected behavior of 0 1 2? You would simply replace the keyword where with let. We know that let is block scoped. So since this is a block, so for every iteration of this loop, you get a different I, and each of the I holds the correct value and no I is replacing the other ones. So for each iteration, we have a fresh I and each callback captures its own private copy and it doesn't allow anyone else to override it. So we get 0, 1, 2. Let's now try to understand what hoisting is. So if you have a JavaScript file, before your code runs, JavaScript will actually scan the entire file and register all declarations of variables at the top of their scope. So virtually JavaScript will take your variable and give it a value at the top of the scope. This particular behavior is called hoisting of variables. But the way JavaScript does hoisting for variables declared using var and variables declared using let and const is different. If you have a variable that has been declared using var, JavaScript will hoist that variable and initialize it to undefined immediately. So if you try to access it before it has been declared, you get this value of undefined because it was initialized by the language itself to undefined. But in the case of let and const, even though the variable is hoisted, it will not be initialized. So JavaScript knows that this variable exists, but if you try to access it before it has been declared, it will throw an error and it will not allow you to touch it before it has been declared. Let's now look at code and understand how this hoisting works. So as we have seen, a variable that has been declared using var keyword, it will be hoisted and immediately assigned the value of undefined. So if you try to access a variable before it has been declared, that will result in undefined. So JavaScript will internally break this single statement into two different statements. So one is the declaration itself without assigning a value. Since it doesn't have any value, if you try to log it, you get undefined. And the second part would be the actual initialization. So JavaScript will take this one line for a variable that has been declared using var. It will break it down into two. The first part would be the declaration. The second part would be the assignment. And if you're trying to assign this variable anywhere before it has been initialized, it will give you undefined because of how hoisting works for variables declared with var. But for variables which are declared using either let or const, we had seen that if you try to access the variable before it has been declared, JavaScript will refuse that and you will get a reference error. So basically var lies. That is because even though the value is 10, you could get a value of undefined if you're trying to access it improperly before its declaration. But in the case of let, the language refuses to give access to that variable before it has been declared. So that is the reason in modern code bases people tend to avoid the var keyword because it could be misleading. It could result in values that are not the correct value. But in the case of let, since you get an error, this is not misleading and you can find what's the code that is causing the error and fix it. So as it is written here, since var's undefined behavior is very dangerous, it hides the mistake. That's the reason we tend to use let, because improperly using let will cause the script to crash and it tells you exactly what went wrong. So at this point, we have understood what scope is and what hoisting is. Let's now understand temporal dead zone, which is a very important topic. So temporal dead zone refers to a forbidden window between when a variable is hoisted and when it is initialized. And if you try to access a variable anywhere in this window, you will get a reference error. So if you have a block starting at this point and if you are initializing and declaring your variable over here, so anywhere between the block start and the point where your variable has been declared, that would be your temporal dead zone. So basically JavaScript has registered the variable during hoisting, but it is logged. You cannot access it in this zone. And this behavior exists so that we don't have any bugs related to what we saw for var, where we got undefined for a value which was misleading. So let's see how temporal dead zone works differently for all the three different types of keywords. So for a variable that has been declared using the var keyword, there is no temporal dead zone. We have seen that this variable gets immediately hoisted and initialized to undefined. So you get undefined. There is no temporal dead zone for variables which are declared using the var keyword. But if you declare a variable with let or const, there will be temporal dead zone beginning at the start of the block till the line where the variable has been declared. So anywhere in between, if you try to access the variable, you get reference error. Same is the case with const. So var has no temporal dead zone. It's pre-initialized to undefined and we can access it immediately even if that is misleading. But for let and const, both sit in the temporal dead zone until their declaration line is reached. And if you try to access anywhere before that, you will get a reference error. But with const, there is one extra rule. It must be initialized at the point of declaration. So you cannot simply write const x. You have to write const x equals 10 or x equals 20 or some value with which you're initializing the variable. You cannot leave the variable uninitialized for const. Alright, so this is another interview question. Take a look at this and try to guess what would be the output for x. So here you have two concepts. One is temporal dead zone and the other one is shadowing. Since you have two variables with the same name, one with a global scope and the other with a block scope, inside this block, the second declaration has shadowed the first declaration, and we know that for a variable that has been declared using the let keyword, it gets hoisted to the top of the block which begins here, and anywhere between this line and the point where your variable has been declared, anywhere in this window, this is your temporal dead zone, and if you try to access x, you get a reference error. Most people think the answer would be 10 because of the global scope of the variable x here. But you need to remember that once shadowing takes over, the outer x completely disappears. If this variable over here was named something other than x, then yes, the answer would be 10, because in that case there would be no shadowing. Take a look at another question. This also uses the concept of shadowing. What would console.log print here? Most people say 10, but think carefully. We also have a variable named x inside, and what would hoisting do to it? So just like the previous question, this would result in a reference error. This is because once shadowing takes over, the outer x becomes invisible. The x inside will be hoisted to the top of the block here, and the window between the starting of the block and the declaration will form your temporal dead zone, and you're trying to access this in your temporal dead zone, so that would result in a reference error. So to summarize the fundamental differences between these three keywords, we need to have good knowledge on these topics. So we took a look at scope, which defines where a variable can be accessed. We took a look at hoisting, where declarations are moved to the top of the scope before the file is run. We took a look at temporal dead zone, which is the window where let and const are locked, and accessing them there would result in a reference error. And finally, we looked at block scope, which is very important because let and const are block scoped variables, and this could lead to interesting situations in which shadowing will cause unexpected outputs. In a real code base, you need to use const by default, but if you know that the variable might change its value, you should be using let, and you should never use var, because let and const can do exactly whatever you want to do with var, and you shouldn't be dealing with the complexities and hidden bugs that var can cause. So that's it for this video. We will continue the JavaScript Fundamental series course and cover other important topics like lexical scope, closures, call stacks, promises, async await, prototypes, event loops, the this keyword, and several important patterns as well. So subscribe to this channel to stay updated and to learn in depth about JavaScript fundamentals and get a good grasp of this language. Thank you.